I'll go ahead and get started then. So thank you everyone for joining today. My name is Nile Wilson, and I'm a data and applied scientist at Microsoft Industry Solutions Engineering. And as Nathan mentioned, I'll be speaking today about writing unit tests for data science code. And I'll be going into what unit tests are, why they matter, and what makes it so different in the data science world versus software engineering. All right, so a little bit about myself. I come from a background of biomedical engineering in academia. I completed my PhD with a focus on brain-computer interfaces, so BCIs, back in 2019. So for the past 3 years or so, I've been working at Microsoft as a data and applied scientist. But my background in biomedical engineering isn't necessarily a direct one-to-one translation to what I do today. So a little bit about this presentation is including my journey as well, coming from an academic background to industry. And hopefully that'll be relevant for some of you as well in terms of learning some new skills and understanding what best practices that you need to implement to really improve your quality of work within the non-academic space. So if you'd like to learn more about me, feel free, of course, to reach through LinkedIn. And there's also the devblogs.microsoft.com/ce/Nile link for more information about me. And also you can see some blog posts that I've written as well. And I do see the Q&A notification bumping up. Do we want to address something right now?
I think we could save it for the end.
Okay, sounds good. All right, so I'll go ahead and move on then. So for today, again, if there's any questions that come up that are really blocking your understanding of the presentation, please feel free to ask right away. Otherwise, feel free to leave them at the end. I'm really happy to go over any of the topics here and also just go through and discuss what might work best for everyone. And so in terms of today's presentation, I'll be also taking breaks here and there, just a few pauses to allow for questions to come in as well, but otherwise feel free to interrupt as needed. Okay, so before we get started, I want to set the stage and make sure we all have the same basic understanding, since some of these terms can mean very different things depending on who you're speaking to and what field you're working in. So first off, what is unit testing? So unit testing is a way of ensuring that code that you write is working as expected. So a unit refers to a small piece of code, a single function with not too much going on inside of it. Typically, you consider that a unit. But when you're thinking about a full solution, it's a lot of different pieces moving together. And while you can also test that larger system, which we may call integration testing, for example, testing each of those individual components is called unit testing. So when it comes to software engineering and data science, this is important for both situations where you want to write code that would be going out into production. So if you have any sort of code that will be customer facing or will be used in customer facing scenarios and has things such as MLOps or continuous integration or continuous deployment, CI/CD, you'll want to make sure that you have unit tests written. So when it comes to the tools for this, there's a few different tools that you can use. When it comes to Python code, I tend to use PyTest as I find it easier to work with, but unit test is also a Python library that could be used for this. All right. So where does unit testing come into play? What are some real-world examples that we can see that really help solidify the importance of this? So unit testing is applicable for pretty much any sort of data science scenario where you're working with production level code. And so just some examples from my previous work, there's a lot of different projects from different industries and different machine learning domains as well. But just to show the range, I picked 2 here that are fairly different that had unit testing as a core component of the solution. So first off, we have a project where we're working in the media and entertainment space, specifically working with Warner Media. So this is a project I got to work on where we were able to use some of the film that they were providing to build a solution to automate scene and take detection using digital dailies, which is like the footage that you get when creating a movie that is running for a long time, and then eventually you cut that down and edit it into the actual final film. And this is a fairly complex solution, and so unit testing was pretty important for ensuring that we're able to have every component work as expected. So if you're interested in learning more about this specific problem and this specific solution, feel free to visit the blog link here, aka.ms/, and I believe someone is going to paste that into the chat right here. On the opposite end, we have something in the retail space. So a recent project where I got to work on forecasting sales opportunities at scale. So for a lot of different time series in parallel. And so with this, we are training and selecting the best from thousands of univariate time series forecasting models for this one. So what specifically was the impact of unit testing for each of these? So for that first example, in the media and entertainment space, with this solution, we were able to automatically identify discardable footage and reduce the storage cost by 44%, which is quite large. And we did so with a precision and recall of 96%. And so the impact of this was fairly large. So what was the role of unit testing here? Why was it so important? So again, when it comes to writing production level code, it's really important that we have these unit tests to ensure that as we build complex solutions or even simple ones, every little piece of code that we're writing functions as expected. We're not accidentally leaving in any sort of hard-coded values or not considering certain edge cases. This allows us to really be confident in the code that we're deploying and ensuring that we have the high quality in the final solution. Likewise, for the retail project, we're able to have high confidence in the performance of our solution, not only from the machine learning performance standpoint, but also from a code perspective. This was a pretty complex solution that required using AutoML to do the training for many models and selecting the best model as well. And having these unit tests really helped solidify our confidence in being able to share this with the customer. We co-developed with them, but being able to ensure that everyone was really happy with the performance and also the transparency in the entire solution itself. Okay, so before I jump into a deep dive of how to actually write these unit tests for data science code, any sort of questions regarding the applications or any of these use cases?
I'd say let's give it about 10 seconds because sometimes it can take a minute for people to type, but there is a question. Maybe we can just start with the question that was asked at the start, and this person's asking if they can learn data science in 1 year.
Yeah, I would say it depends on your background. It depends on your background for sure and what you consider learning data science is. There's a lot of different levels of proficiency. And because it's such a large field that's evolving fast and is always changing, if you mean learning data science in a year is mastering absolutely everything, then no, 1 year definitely will not be enough. But if you have background already within statistics or computer science or working with data, and you're interested in the basics and getting started, then yes, you can definitely get started within a year.
Yep. Start with building a foundation.
Yes.
All right, I'm not seeing any other questions about what we just went over, so why don't we go ahead and continue?
Great, sounds good. Okay, so I'll go ahead and continue into this deep dive then. So when it comes to data science code, there's a few different common scenarios or common areas that we'll see unit tests be applicable for. So for data science code, there's a lot of data pre-processing that usually has to happen. So our data wrangling, cleaning things up, and formatting them into the way that we want them to be to feed into the models, feature engineering, etc. All these functions that we're writing for data pre-processing, if it's in a production setting, we'll want to have unit tests for them. Similarly, if you have any sort of helper functions to assist with formatting things for model training or formatting the results as well, that's something you'll want to write tests for. And of course, anything that works with data in terms of evaluating it and deciding the next steps or doing whatever needs to come next should also be tested. So this is pretty much the full gamut of the data science lifecycle in terms of once you have a model cited on. So we'll be talking about unit tests in the context of data science code after exploration. Okay, so before we get into the testing itself, what does the code look like? So as many of you are likely familiar with, the code for data science can be in a few different languages. Today I'll be focusing on Python, but even just within that broader space, there's a few different stages when it comes to writing data science code. Usually I'll start out in a notebook so that I'm able to quickly iterate on working with the data, fastly developing things, and just being able to iterate pretty quickly. And it's nice to have a visual immediately for what you're working with. However, when it comes to the exploration phase, you don't necessarily really need to write unit tests. It can be helpful, but because things are changing so much and some functions that you write or some code that you use might not necessarily end up in the final solution, it's not really necessary to write unit tests at that point. However, once you get to what you believe will be closer to the final solution, and once you're moving things into scripts, then yes, you'll want to start writing unit tests. So first thing first is breaking the code down. And Nathan, I do see your video actually, so feel free to interject.
So we do have a question about, do you also do functional testing in each dev environment?
Oh, yes. So when it comes to functional testing, definitely. So in terms of this talk today, I'll be focusing on unit tests specifically. However, integration testing, functional testing is all very important as well. So I do highly recommend doing that within your productions environments and also in dev before you deploy to QA or to prod.
Perfect. Sounds good.
All right. So when it comes to the code, first thing first is, even if you're converting your code, let's say from a notebook into scripts, if you copy and paste things exactly as how they were in the notebook, it might be a bit messy. One of the key things is to break down the code into nice chunks or nice little units such that it's easier to test. So when it comes to unit testing, you want to make sure that the functions that you're testing are pretty modular and are not massive and doing a lot of different things. Another thing about the code is just personal preference and also coding best practices, just to include doc strings and type hinting. So ways to ensure that's easier to read your code once you come back to it, and also for anyone else reading your code as well. And lastly, it's important to organize your code into different functions, but also organizing where those functions lie is important as well. So if you write any sort of utility scripts and organize your functions into those, I find it easier to work with that way. Okay, so what does a test look like? So unit testing can take on a few different forms, but this is the format I like to use. When it comes to defining the tests themselves, I start out with a preface or prefix of test underscore, and then the original function name. And so this is within a file called test, whatever your script name is, .py. And so this is a file that contains all the tests for that particular script that you're testing. And with this, you'll see that on the function, we have a happy path appended at the end. I'll typically append happy path or exception, depending on if it's a test to test if the function is working as expected or if it's doing the error handling correctly. When it comes to the test format, I like to think of the 3 A's. So we have arrange or assign, act, and assert, where arrange is the space for you to kind of build up the arguments that are going to be fed into your function. So this is things like loading any necessary data, mock data, formatting things as necessary, going into act, which is calling the actual function you're testing, and then assertion, which is assert, which is making sure that the expected values are what you're actually getting. And yes, Nathan, I do see.
So I'm going to interrupt you. So,
yeah.
So on average, what percentage of time of your coding do you spend on unit testing? Does it become a lot of the same things that you plug and play eventually?
That's a good question. So it depends. it really depends. So I'll say if I'm just considering the amount of hours I'm putting into writing code itself, let's say I'm writing some basic small solution that has like a few files for regular Python scripts for the functionality, and then a few as well for the tests. I would say majority of the time for sure is developing the actual code, because there's a lot of trial and error in terms of that creation. And then I would say, depending on the complexity, like 20 to 30% of the time could be allocated to unit testing.
Okay, and then I had another one for you. So does that mean I'm not going to try and pronounce this person's name, so apologies to this person, but does that mean unit testing is not required if the model will not be deployed into production?
Good question. So it's depending on who you're working with, things may or may not be required. I would still recommend it. If you have time, unit testing can be really helpful for catching just any sort of issues before they become, like, especially any sort of silent issues.
Mhm.
And for example, in grad school, there was an issue where I didn't really know about unit tests. I definitely could have benefited from them because there was some sort of experiment that I ran and the analyses looked great. I was ready to present this to the group. And then I realized, oh no, I hard coded something by accident and I had to, fix things, rerun them, and like things were drastically different. So if I wrote unit tests for that code back in grad school, I would have caught that before I got all excited. So the same thing applies within data science as well. Unit tests can be helpful for catching any sort of silent issues, but it's not absolutely required if you're not going into production setting.
Okay, perfect. And then we have two more, just two people asking for elaborations on a few things.
Sure.
The first is, can you elaborate on, oh, it's in the chat. There it is. Can you please explain what you mean by different utility scripts?
Yep. So I wish I had a screenshot here to show, but essentially, let's say that you have a Python script or some sort of notebook you're working with, and you want to import some code that you wrote.
Mhm.
Let's say you have a function called, I don't know, filter like data or something like that. And you define that within some sort of .py file somewhere else that's not where your notebook is. You can consider that utility script. If that .py file is something like generic utils.py, you import that module, then that is considered your util script.
Okay, and the next one before we start moving on, because there are more questions, but I want to make sure we have enough time to get through the presentation. Can you elaborate on happy path versus exception?
Yes, so I will say for the sake of time today, I won't go through every single slide I have available. I actually do have some hidden slides that elaborate more on exceptions. And so once the slide deck is sent out afterwards, definitely feel free to review that. But short answer is that happy path is what I like to call the test for making sure things are working as expected with input that is valid. Exception tests are for when the input is not valid. Does the function handle the errors as expected?
Okay, perfect. And I know there have been a couple of questions about will the PowerPoint be available? You just heard it from Nile herself. Yes. Okay. All right. Now I'll let you continue. And again, I'll pop up when there's more questions.
Sounds good. Oops. All right. All right, so moving on from the test format then. So for sample data, so data science, we're working with data. It's the core of everything that we do. And naturally, when it comes to testing our code, we also have to work with data. However, a key thing is that we don't want to use our full actual data set when it comes to running unit tests. One of the key reasons is that the focus is on testing the functionality of the code that we've written, and it's not necessarily about the results or the data itself. Another key thing is that unit tests, you want to be able to run those locally. So if you have a large data set, let's say like a terabyte or petabyte even of data, you don't want to be feeding that through every single time you're running a unit test. You'll want a really small sample. And so another thing is when it comes to running tests locally, a common practice is to save some of that sample data directly inside the repository that you're working in. And to minimize the size of the repository, you don't want to have any sort of larger than necessary sample data saved for unit testing there. So as you can see in the image, we just want to take a small piece of the puzzle, a small part of the data to run our tests. And an important thing is if the data you're using is sensitive, it's private, sensitive data that you shouldn't be uploading to a repository in the first place, then don't use a subset of that data. Instead, use some sort of synthetic data that's similar or some sort of open source or your own generated data that is similar enough and meets the specific criteria, but is not, wouldn't compromise any sort of security or privacy rules. Okay, so before I get into this, I just want to state real quick that this is the core concept that I want to get through the presentation today, and it's mocking. This is something that I struggled with quite a bit when I started my journey for learning data science unit testing. So I'm trying to break it down in these presentations today to make it fairly straightforward to understand, but if you have any questions, definitely please feel free to ask them. And I just want to actually take a moment to share a little bit about my history when it came to learning unit testing for data science code. So as I mentioned earlier, my background's in biomedical engineering from academia. And so at that point, joining Microsoft in 2019, I had never written a unit test before. When I had joined, I was tasked with learning a lot of new things, getting up to speed with the industry, and making sure that I learned some software engineering best practices to be able to work effectively alongside software engineers and other more experienced data scientists within production level settings while working with customers. So one of the first things I did was I had to learn what unit testing was. And at the time, there really were not a lot of resources at all. In fact, most of the resources that were available were very strongly written for software engineers or for people with a strong background in software engineering. While I had a little bit of experience here and there, the assumptions and the lingo just really was not conducive to what I needed to learn and what I needed to do. And so I really struggled at first, and I had to reach out to a lot of different data scientists within the company, colleagues who were more senior, had more experience about unit testing. And luckily, through experience and with their guidance over time, I was able to learn how to do this and improve my skills as well. But this concept in particular is something that can be tricky. And so this took me a bit of trial and error to get used to. So, all right, enough with that, and I'll go ahead and move into what this is. Okay, so mocking is a way to simulate functions that are called within what you're testing. It's also a way to simulate the output of what you're calling. So let's say, for example, we have a function that we're working with, not a test, but just the function. Let's say we're working with format historical data frame. You'll see within format historical data frame that we have another function that we're calling inside of it called filter columns. Now on the right-hand side, you'll see a unit test written for this, just the simple pared down version. And you'll see that there's also this reference to format historical data frame here. Now you notice that this is a mocker.patch call. And what this is doing is this is allowing us to say that when we call format historical data frame, instead of actually using filter columns as specified there, let's actually just automatically return the return value of an empty data frame. So once we actually get to the act section of our unit test and we call our original function format historical data frame, this is what it looks like. So at the top, you'll see what the function looks like normally when you call it. But in our test case where we do have the mocking, you'll see that the line that originally called filter columns is now replaced with the return value. So instead of filter columns actually being called, we are mocking, we're patching that, we're saying, okay, don't actually call that. Let's just assume that the output is an empty data frame. And so that allows our test to run for format historical data frame to instead focus on the functionality of format historical data frame, rather than focusing on the functionality of the functions that are called within it. Okay, this is a, I think, fairly simple example compared to how complex it can get, but hopefully this makes sense to everyone. If not, are there any questions related to this at this point?
I'm not seeing any questions yet, and that either means, all right, I guess we do have one question.
Okay.
Why is that an advantage?
Yes, good question. So here we go. Why? So should I mock, and understanding when and why not to mock? So the reason that we want to do this is that whenever we write a unit test, we are really making sure that it's the functionality of that particular method or that particular function. That is what we're testing. So when it comes to unit testing, you want to make sure you write something for each of those functions that you write. In the case of our previous example, I'll go back to that real quick. In this case, we were writing the test for format historical data frame, but we would also have a separate test for filter columns. So within the test for filter columns, that's when we can actually test that as expected. We can make sure the output is correct, things like that. But when it comes to testing format historical data frame, we've already tested filter columns, so there's no reason to have that go again. We can just go ahead and filter, reduce the amount of time that it takes to execute the test, especially if you have more complex functions, if you know that you can work with a particular output to mock. And so in terms of when should you mock, you do want to mock imported library calls if they're not small essential operations, so things that can be a bit larger, especially any sort of custom functions as well that you don't already have tests for, definitely mock those. And calls to external services are things you usually want to mock as well. So as I mentioned before, unit tests should be able to run locally. So if you have any sort of calls to external services that would require a connection, and there's a lot of other things that could go wrong there, there's different sorts of tests that you can do to ensure that your full solution works end-to-end, which includes connecting to different services. But for testing small independent functions, it's typically not necessary. Also, you do not want to mock custom functions you have that don't have any tests already, so write those tests. And also any sort of basic necessary operations. So let's say within your function, you need to read in a data frame, or you need to convert something into an array. These basic things, there's no need to mock them because they are very basic operations that need to happen for the rest of the function to actually work as expected. Right. Before I go any further, any other questions on mocking?
I was gonna say I was gonna give it a second before I said no, because because of last time, but I'm still not seeing any pop up, so I think you're good to go.
Okay, sounds good. And again, if anyone has any questions at the end, definitely feel free to ask. Okay, so this next thing, parameterization, is something that I felt really helped me step up my unit testing game. It's something that allows us to cleanly test multiple sets of input for any of the tests that you write. So instead of writing, let's say, 5 different tests for the same function with different edge cases and different types of input or different categories of input, this allows us to use that same test code and just say at the top, these are the different sets of input that I want to run through it to test. And so in the case here, you can see we have that pytest.mark.parameterize. And then that first line afterwards is just stating what are the arguments that we're going to be represented within those sets below. So in this case, we have a path to a forecasted data frame, as well as a KPI value. And in each of those sets or parentheses below, or tuples, we can see that we have a path and then some sort of KPI value. So each of these sets of parentheses are being fed into the test. So this test actually runs 3 times. And I feel that this is really important when it comes to handling edge cases as well. So this just has 3 examples, but sometimes I'll have tests where the parameterized section is quite extensive. So I'm making sure I cover a lot of different ground to make sure that the test runs as expected. So that's also really helpful for when, let's say I want to improve a function or make some changes to it. Having all those different sets of input, make sure that when I run the test again after making changes, that it clearly goes through all different sorts of options and the DCO.
Yep, and this kind of goes back to mocking. So this person wants to know, how would you do mocking when the actual data matters for the functionality you are testing? And there's a second part too, but we'll start with that one.
No problem. So when it comes to mocking and when it comes to the data itself, there are definitely times where you have those functions where the intermediate functions will process that data. And you'll need to rely on that processed data to actually continue through the actual main function that you're working with. So in that case, you just want to make sure that you're providing mock data that is appropriate. So in the example that I provided, we had a return value of an empty data frame, and that was just very simple, whatever worked for that specific instance. But there are cases where you'll want to say instead that your return value is, let's say, some specific array that you know is going to be representative of data you would have at that step. So that's an example of mocking data as well. You could save that as like a NumPy file or CSV file, for example. Save that within the test data section of your testing folder, and then load that in during your unit test to ensure that you can feed that in as mock data.
Okay, and then and you may have already answered this, so let me know if you did, but how can you mock for a non-generic function that depends on the data? If that makes sense.
Got it. So let me go back actually just a little bit. Okay. So here we go. On the right-hand side, again, this is showing that mocker.patch function. When it comes to mocking a specific function, you don't need to worry about the input into that function you're mocking. So in this case, filter column should take in two arguments. We have historical data frame and some sort of config. Note that when we're making that mocker.patch, there's no reference whatsoever to those input arguments. So whatever goes into that function doesn't matter, since we're actually not going to be calling it itself. It's more about what is returned.
Okay, sounds good. And then we also have a question about parameter. The next slide.
Yes, parameterization.
So is there a way to automate the parameterize function as in auto-generating the test data to be used in the function?
Oh, that's a good question. I haven't tried it. There might be a way to do it, but I honestly don't know. But it's worth looking into because I feel that could be helpful, like setting a range of values, for example.
Okay, that's it. We can go forward.
Awesome. Okay, so I know there's a few other topics that I definitely could have covered, but in terms of sake of time, just want to cover these core concepts when it comes to unit testing for data science code. So first off, just reiterating that unit testing is a must-have for production level solutions. So for anything that is going to be customer facing, anything running continuously or running through large amounts of data are really important. You want to make sure that you have unit tests written for your code. It helps promote code quality and also helps you catch mistakes early on. It also helps you think of better ways to improve the code. I was actually running unit tests this morning for something and realized that there was a functionality that was missing. And so while writing tests, I actually edited the function itself, improved it, and added that into the pull request as well. So really key thing here is that data scientists and anyone here should feel empowered to write unit tests. It might seem a bit daunting at first, but there's definitely more resources available now to help out with that. So this presentation is just one small example. I do have a resources slide here where I believe the links will be posted into the chat and also available in the slide deck. But there are different articles out there now, example repositories, and different documentation. So I highly recommend giving these things a read and also experimenting yourself with writing these unit tests.
Awesome, thank you, Nile. And we got a question asking, can we get a link to these test codes and README file with steps on how to perform such testing? Yes, they'll be in the resources. The link was just posted on Zoom if you want to click there. And also when we post the recording on our website as well as YouTube channel, we'll have all of these links listed out as resources, so you will have access to them. If you're on Zoom, that means we have your email address and we will also email them to you. So don't worry about missing out on them now. You will have access to them once the recording is posted as well. Okay, so now we do have some extra questions, of course. So we're going to go through them one by one. So this question was asked more towards the beginning of the presentation. And this is from, I think I pronounced their name, Sharif. So does that mean TDD won't work with data science projects?
Sorry, what was the acronym again?
TDD.
TDD. am not sure what the acronym stands for.
I am not either.
Okay,
So,
if this person could reiterate, then
it
that'd
might
be
be
appreciated.
test-driven development.
Okay.
Okay.
I would have to look into the specific definition of it, but if it's something, for example, saying that you need to develop tests with everything as you go, then I think that could be possible with data science code, but it's not standard within the workflow since exploration is such a huge part of data science. Unit testing typically comes in after the exploration phase.
Okay, perfect. And it might have been just you and me not knowing what test-driven development was. It seems like everybody in the chat knows what it is. So thank you all. Next question is, which role does the unit test work? Like, is it a data engineer? Is it a data scientist? Is it the person who develops the code? Who is it?
Yep, so it depends. It depends on what kind of team you're working with and what environment, but in my experience, typically the person who wrote the code would write the unit tests, which would be the data scientist. Unless you intentionally want to do a knowledge share and help other people gain a better sense of ownership over the code as well. So let's say you're co-developing something with a customer. And let's say I wrote the initial functions, but I wanted the customer to feel more comfortable and have a deep understanding of the code itself. In that case, I might ask them to write the unit tests such that they're really forced to look through the code and understand exactly what's going on.
Okay, and we have a little bit of a clarification on test-driven development.
Sure.
Test-driven development is when you write the test first, and write the code to pass the test.
Oh, okay.
I don't know if that changes things, but that's what it is.
I feel like you definitely could do it, but I think, again, since when it comes to data science life cycles, typically you start with the exploration phase and then you will kind of bring things to production. Typically, the code you're writing that will go into production has its origins from the exploration phase. So in that case, you're already starting with existing code rather than starting with a test.
Okay. Okay, next question. This person says, thanks and sorry for interrupting again. Don't worry about it. Do you have a software engineering guide or best practices to follow in an industry-based data science project?
Yes, so we go back to this list of resources real quick. So resource number 3, the Code with Engineering Playbook, I would say is pretty valuable for understanding how to write production level code, especially in a customer facing setting, but even just for yourself internally as well. There's a lot of good resources there, and it's written with having software engineers and data scientists and program managers in mind. So the machine learning folder specifically has a lot of machine learning best practices. And outside of that, above it, there's also different resources for software engineering.
Perfect. And again, just a reminder, these will be posted with the recording, so don't worry about trying to type them out or copy them down. There'll be plenty of opportunities to grab these. Next question is from Jack. So how does a release pipeline for data science differ from that of a software pipeline? Does the environment differ significantly to accommodate for mocking, etc.?
Good question. So the environment doesn't have to be significantly different to enable mocking. As long as you have some sort of environment set up where you can run your code. Let's say, for example, you have a build pipeline for your repository, just to make sure that whenever a pull request is created or merged into the main branch, that there's a certain series of checks that are made. So you can include the unit testing as part of that. That can still use the same environment as all the other testing as well. The only difference is you'll want to make sure you have the data available somewhere for testing. And again, not your full data set, but just whatever you're using for testing. So if you have a folder in your repo called test data, that's all you'll need.
Perfect. And this person, John, maybe you joined late or maybe just missed something, but the presentation seemed to cover most of the things you would do for writing unit tests in general software engineering. Are there any, so outside of software, what we would do for software engineering, are there any special considerations for data science code?
Got it. So specifically for data science code, I think the key thing is that sample data portion. When it comes to things like trying to test functionality of a particular model training, again, I would recommend mocking things that are from imported libraries. So if you're importing something from I don't know, from PyTorch or something like that. That kind of code typically already has its own tests, so you don't need to reinvent the wheel and test those as well. So in those cases, I recommend mocking those calls and returning test data that's appropriate for your situation.
Okay. And then last question for now, unless more pop up, how frequently should someone run unit test cases on production code?
Yep, good question. So again, that depends on the specific solution, what's needed for the business value, but typically you'll want to run unit tests any sort of time that the code is changed in any sort of way. So if you're creating a pull request, for example, into a repository, you'll definitely want all the unit tests to pass before that PR can be merged.
Okay, perfect. Sounds good. We do have a couple of more questions pop up, but I'm going to let people continue writing. I'm actually going to steal the screen from you for a second. I want to tell people about our code, or not our code, but our event for next week.
Sure.
So let me just make sure I'm grabbing the right screen here. There we go. All right, so Nile, I'm hoping that we are seeing a crash course on data wrangling using SQL.
Yes.
Perfect. So next week, December 7th at 12 p.m. Pacific, so the same time as today, we'll be doing a crash course on data wrangling using SQL, and this is going to be presented by Selma Dojic. She's a manager of analytics, COE, and strategy at Carter's. But in this session, if you are new to SQL, you're a beginner, you're trying to learn, this is probably a session that you want to be a part of. Selma's going to present it from the expectation that people have little to no experience in SQL. And by the end of the session, you're going to know how to query a data set. You're going to do some joins, append data, apply filters to your data sets, and create new data fields. So again, if you are new to SQL, and SQL is something that, especially at Data Science Dojo, we tell all of our data scientists, if you don't know SQL, we're going to help. We're going to teach you it because you need to know it. If you're new to SQL, definitely something I think you should think about joining. You can RSVP on our website by just going to datasciencedojo.com/events and clicking on the event, or you can also join us live on LinkedIn, Facebook, Twitter, or YouTube. All right, and so that's all I had. So now we can. There's a few more questions popped up while I was talking, so we can go ahead and answer those now. One person is asking if there was a recording, and it's okay to join late. Yes, there's going to be a recording. We'll send you an email, or you can find it on Data Science Dojo's YouTube channel as well as our website. And it'll also include all of the resources that Nile has shared with us today. All right, let's get through some more questions. Is there a list or of a walkthrough, like a to-do list, step by step on on unit testing or docstring for data science to production?
Yeah, so I would say check out the resources that I listed. The blog post at the very top, I think, is helpful at explaining that. But just quick answer, those 3 A's that I mentioned, the assign, act, and assert, I think that's your basic skeleton that you want to go with when writing data science tests, or just unit tests in general.
Okay. And then how do you handle the scenarios where you get new features as input into the pipeline, and how is the model training handled in that case, especially if the existing model doesn't support continual training?
Okay, so in this case, I feel like it's typically necessary to have some sort of pre-processing functions or helper functions to bring that data into the model in the first place. And that's where you can put in those checks.
Okay. And then this would actually probably a good question to end on by Gordon. On projects you have worked on, how have you balanced time spent on unit tests versus model iteration or exploratory analysis? And do you run into barriers with leadership or management for not prioritizing unit test development?
Yeah, good question. So it depends on the stage of the project. Luckily, with my work, we have distinct phases. So we have the feasibility study phase or exploratory, like data analysis workshop area. So like that period, unit testing is not really in the picture, and I can focus on the exploration. However, once we get to the portion where we're working with a lot of engineers and we're breaking things to, into pipelines and production level, that's when unit testing is pretty important. So luckily, our leadership's pretty understanding. They recognize the significance of unit testing. So I haven't run into any issues regarding making sure I have enough time to develop those.
Okay, perfect. And Nile, that is all the questions we have today. So thank you so much for being here. For everyone that joined, thank you again.